Problem number 10. Let d and alpha be constants. Prove that the polar form, r is equal to d secant of theta minus alpha, describes a line in the xy plane. So there's two issues here. There's two things I don't like to see in this problem. That's going to make it tricky. The first is a secant. So usually I'm working with polar coordinates. I like to see cosines and sines because I know that r cosine theta is equal to x, r sine theta is equal to y. A secant, I don't really like that. The other thing is that I'm used to thinking about, cosine of theta or sine of theta. I'm not used to thinking about cosine of theta minus alpha, sine of theta minus alpha. I don't really like the difference in there. So we're going to do two different manipulations that's going to allow us to solve those two issues. So first is I'm going to rewrite this. So secant is just 1 over cosine. So I can rewrite this as r is equal to d over cosine of theta minus alpha. And then I can move this to the other side. R times cosine of theta minus alpha is equal to d. And so we have that parentheses is on the wrong place. We've solved one of our problems. Now we have a cosine instead of a secant. R cosine theta, that feels like something we can deal with, but we still have our second issue here, which is that it's not cosine of theta, it's cosine of theta minus alpha. So the second thing that we need to use is an angle subtraction formula for cosine. So here is a useful identity. Cosine of a minus b is equal to cosine a cosine b minus sine a sine b. This is a very useful identity to know. Even if you don't have it memorized, knowing that it exists is very helpful. And so I'm going to replace this up here. I guess theta becomes, a becomes theta, b becomes alpha. And this produces r times cosine theta times cosine alpha minus sine theta sine alpha. All of that is equal to d. And if I open up this multiplication, I get r cosine theta cosine alpha minus r sine theta sine alpha. All of this is equal to d. Now what decisions can I make here? Well, this is y. And this is x. And if alpha is a constant, cosine alpha is also a constant, sine of alpha is also a constant. So what do we have? We have cosine alpha times x minus sine alpha times y is equal to d. Constant times x minus a constant times y is equal to d. That's an equation of a line. You can certainly manipulate it to put it into a different form of the line, but this is a perfectly valid form of the line right now. In any case, we have definitely proven that this describes a line in the xy plane. Key step in this problem, probably doing this, knowing this cosine of a minus b is cosine a cosine b minus sine a sine b fact right there. If you don't have it, you're probably not going to be able to answer this question.